Now, we previously noted that our dot product, or scalar product, was the multiplication of the magnitudes of our x, y, and z component terms summed. Now we want to prove via a component-wise multiplication considering the magnitude and directionality of our vectors. That is, if we have vector A defined as axi hat plus ayj hat plus azk hat, and we dot it with vector B that's expressed as bxi hat plus byj hat plus bzk hat, that we do indeed get axbx plus ayby plus azbz. To begin, we have axbx times the quantity I hat dot I hat plus axby times the quantity I hat dot j hat plus axbz times the quantity I hat dot k hat. We know I hat dot j hat is 0 and I hat dot k hat is equal to 0. Therefore, axby and axbz are going to be equal to 0. Continuing on, we have aybx times the quantity j hat dot I hat plus ayby times the quantity j hat dot j hat plus aybz times the quantity j hat dot k hat. J hat dot I hat and j hat dot k hat drop out, and we are left with ayby. Lastly, we have az bx k hat dot I hat plus az by k hat dot j hat plus az bz k hat dot k hat. K hat dot I hat and k hat dot j hat go to 0, and we are left with az bz. Thus, we indeed have axbx plus ayby plus az bz.